Now, hopefully you remember from our exponent section, if you were with us, that we went through all of the we went through all of the laws for our exponents, and we spoke about how and when to apply each one. So I'm very quickly going to go through the laws that we need to know, and we're then going to apply that to some examples as we go along. Right, so our first law of exponents deals with multiplication. Guys, when I'm done with this, I would definitely take a screenshot of these laws so that you have almost like an information sheet that you can always refer back to. So the multiplication law tells us that when I've got two bases that are the same and I am multiplying them together, so in this case, x cubed times x squared, my law tells us that I need to go and add the exponents. And so this gets me a final product of x to the power 5. So here, the multiplication law tells me to add the exponents together. Okay, we'll deal with things when we've got coefficients and so on, but the basic sort of algebra, working with the variables, is you add the exponents. When we then get to our second law of exponents, I just want to move that over. Our second law of exponents now deals with the opposite or the inverse operation, which is division. Okay, now hopefully it sort of makes sense that because multiplication and division are inverses of each other, if we are now going to divide the same basis, so let's say we've got x to the power 5 divided by x to the power 3, our law now tells us that we have to take the top exponent, so the numerator's exponent, and subtract the denominator's exponent. And that will allow us to simplify our exponent or our base to whatever the quotient is from that. Please wait, guys, in the chat. I'm getting there. I've only done 2 laws. We've got 4 laws as well as a definition. If all questions aren't answered, then you can ask. So second law tells us to subtract or minus the exponents when we are dividing. Right, law 3 and law 4 sort of go hand in hand. So I'm not going to separate them. I'm going to do them all together because we have discussed them each separately. Essentially, law 3 and law 4 are the distributive laws. I should say distribution. And basically what this is when we have got a power raised to a power. So a very basic sort of first example is if we had something such as x squared to the power of 3. Now we know that that means we're multiplying x squared 3 times. What my law tells me to do is it tells me to multiply those 2 exponents. This is why we have the distributive law. We distribute the outside exponent into the bracket. So we are multiplying exponents. This then gives me my product, which in this case would be x to the power 6. So that's law 3, essentially. Law 4 is just an extension of this, where we have got multiple factors inside our bracket. So let's say we've got 2x squared y cubed all to the power 4. Our law tells us that we need to distribute. What you need to remember, though, is that this 2 does have an exponent. And again, when we do some examples, we'll chat again about this. But the outside exponent needs to distribute to all of my exponents inside my bracket. And so what that means is this simplifies to 2 to the power 4, x to the power 8, y to the power 12. Again, we are multiplying all of our exponents. And so we are able to simplify. Again, when we get to these examples, I will chat about it. Right. So those are essentially the laws that we've dealt with. We also dealt with one definition this year, which sort of leads on from our division law. And this now goes to Nelson's question of what happens if our exponents are the same. We then dealt with, or we spoke about our first definition within exponential exponents, which is the power of 0. that is supposed to say power. Sorry, I don't know what happened. Of 0. Okay, so this is now where Nelson has asked the question, what happens if the exponents are the same? And this is where we deal with it. So let's say, for example, we have got x to the power 3 divided by x to the power 3. Now, our second law of exponents tells us that what we should do is we should subtract these two exponents, top minus bottom, and that gives us x to the power of 0. But what we need to remember, and we do know this, is that any time we divide anything by itself, so if we had 3 divided by 3, or if we had 271 divided by 271, or if we had negative 23 divided by negative 23, or if we had x cubed divided by x cubed. Anytime you divide any value by its identical self, you are getting 1. That is always true. And so what this actually means is that when you have a power of 0, you are actually working with a value of 1, because anything divided by itself is 1. So those are essentially the 4 rules that we need to know. There's 3 laws, 1 definition. You learn a second definition in grade 9, and you learn later or more definitions later on in maths. But those are sort of the 4 things that we need to know when it comes to exponents. Right, now I saw no pretender was struggling to see the screen, so I'm just going to quickly stop sharing my screen and reshare it. For grade 8, I strongly suggest you take a screenshot of this so that while we are going through the examples, you are going to be able to refer back to which law we are applying where. So take your screenshots. Remember, guys, we ask questions on the chat. We only raise our hands when I tell you to, and any questions, any concerns, any answers you have, you pop there on the chat. Nothing here is new. We've done exponents before. We now need to be able to apply them to examples. Again, if you have questions, please put them on the chat. Is anyone else still struggling with the screen? Because now I've shared and reshared it. Okay, I'm going to take the lack of silence as yes, we're all fine. No, right. So if we go and have a look at some examples in terms of working with exponents. Now, guys, what you need to remember is that we are going to combine algebra and exponents together as we move along. And so the complexity of algebra does increase. So whenever we are looking at examples, there's a couple things we want to remember based on or depending on the situation we have. So if we look at example 1 here, we have got the product of 2 values. We've got 2a times 3a squared. Now remember, whenever you are multiplying or dividing, we want to remember SNV, signs, numbers, variables. So when it comes to this example, that's exactly what I'm going to do. My first thing that I double check is my signs. Here I've got a positive times a positive, no issue. I know I'm going to end up with a positive answer. Then I move on to my numbers. When I say my numbers, what I'm talking about are the coefficients to your variables. Coefficients. So we are now looking at the 2 and the 3. Those are the coefficients. We've spoken about coefficients at several points. So go and have a look at the videos if you're not too sure. But those are the numbers in front of our variables. We now multiply those. So 2 times 3, which gives me 6. Then I move on to my variables. And now, because I've got exponents here, I need to go back to my exponent laws. So remember, my first law of exponents dealt with multiplication. My first law of exponents told me that if I'm multiplying the same bases, I add the exponents. Now remember, any variable that has no exponent written there actually has an exponent of 1. And so what we are doing is we are saying a to the power 1 plus 2, simplifying for me to a cubed. So that is me dealing with my variables. And that therefore means that I've simplified to get a product of 6a cubed. And this is all through using SNV. This is through using just our knowledge of how to multiply numbers, as well as our application of our exponent laws. So here, because we were multiplying, we had to apply law 1. And we just had to remember our signs, numbers, and variables for multiplication. Right, so if we have a look at question B, and obviously, gave myself way too much space this time. If we have a look now at question B, these are sort of the types of questions that you need to be comfortable with in algebra, where you have a fair amount going on and you need to be able to deal with it. But again, this is where and why I often say to you, don't rush it. Do it step by step. There's no reason to try and get it done all at once. We go step by step. Again, in question B, we are only multiplying. So what that means is I need to apply law 1 of exponents. And once again, I'm going to apply my S in V. So starting with my signs, all of these are positive. So positive times positive times positive gives me a positive. So I've got no issues there. I know my answer is going to be positive. And now I move on to my numbers. So remember, these are the coefficients. 4 times 6 times 2. So if we just write that out, 4 times 6 times 2. You can do multiplication in any order you want. So whatever's easier for you, I'm just going to work left to right. 4 times 6 is 24. That must then be multiplied by 2, which gives me a product of 48. So in multiplying all of my numbers together, I get 48. Now I have to go and work with my variables. What I need to be careful of, though, is that not only do I have the variable x, I also have the variable y. And it's really important, guys, that we remember that our exponent laws only apply to the same bases. Okay, so we need to deal with x and y separately. If I start with my x's, I've got x to the power 13 times x to the power 8 times x to the power 3. My exponent law tells me to add all of those exponents together. So I'm going to say x to the power 13 plus 8 plus 3. And so that gives me x to the power 24. So again, we deal with the different variables separately. I also need to deal with my y. So I've got y to the power 12 times y to the power 30. My exponent law, when I multiply, tells me to add these exponents. So 12 plus 30. And so my y simplified is y to the power 42. And so now that means I can go and write this down with my answer. I've dealt with the signs, I've dealt with the numbers, and here in pink, I've dealt with the variables. So my sign, remember, was positive. The numbers came to 48. So I've got 48, x to the power 24, y to the power 42. And I have gone and simplified that product for myself. So guys, like I said, this question B is way more typical of what we expect you to be able to deal with. We generally start you off quite nicely with something like A, but we do expect you to be able to deal with questions like B. And questions like B, it's easy to make a mistake if you rush it. And so that's why I'm teaching you this tool of SNV, to make sure that you don't rush and to make sure that you do get the correct answer. Right, so while you're taking a screenshot, if anyone has any questions, now is the time to raise your hand. Yolanda showed you how to do that at the beginning of the lesson. So if you've got questions, raise your hand so you can ask. Otherwise, you're taking screenshots of these two examples. And again, grade 8, remember, there are whole videos of this section on the website and YouTube. BK?
Oh, ma'am. Okay, ma'am. What happens if there's a negative, ma'am?
The exponent.
Yes, ma'am.
Okay, so yeah.
If the exponent and the variable, of some of the part of the equation has a negative, what happens then?
Okay, so it'll depend where the negative is. We don't deal with negative exponents in grade 8. There might be times where we get one, but there's other ways to deal with them, but we don't actually deal with negative exponents in grade 8. What we could do is we could give you a negative coefficient. So for example, in this first question, I could have given you, say, for example, negative 2a times 3a squared. And then it's just a case of a negative times a positive is a negative. So you'll have to deal with the sign of your coefficient. I can't remember if I have any negative exponent examples. It isn't part of the grade 8 syllabus. If we do come across one, I'll show you how to do it. But yeah, you actually only deal with negative exponents next year in grade 9.
Okay.
Okay.
What do we? Okay.
Right, guys. So all right, people are having a problem with the screen. Yolanda has already put on the chat of another way that you can deal with this. So please do try that, guys. It becomes a bit disruptive when we have to stop sharing my screen and reshare and stop and reshare. It becomes problematic. So follow what Yolanda's put there on the chat. And yes, as Batali said, if you can't focus, if you are not paying attention to what's happening, then bye. Alrighty, guys. So let's have a look at question C over here. Now, again, hopefully what we see is that we are working with products, or I'm working with multiplication, and I know that because I've got brackets. Now, often, and this sort of goes back to BK's question, often we use brackets to illustrate multiplication when we are dealing with negative signs. It just helps identify, distinguish the fact that there is a negative and I need to be mindful of that. So once again, grade 8, in looking at this question, I'm going to deal with, or I'm going to use SNV to help me. It's annoying. So signs, numbers, variables. If we just look at the signs, we've got a negative times a negative times a positive. Now we know a negative times a negative gives us a positive. And if we then have that positive times another positive, we end up with a positive. So my overall answer sign here is going to be positive. So that's my signs dealt with. Now I look at my numbers. So I look at the coefficients 2, 3, and 4. Notice I'm not including the signs because I've dealt with them. They are dealt with. They are done. I've sorted it out. 2 times 3 is 6. 6 times 4 is 24. And now I can go work on my variables. Now again, grade 8, notice that there are 2 different variables here. You've got M as well as the variable N. So you need to be mindful of this when going to simplify your variables. So what I'd like from you in the chat is I want a final simplified answer to this question. So once you've dealt with your variables, what do you get as your answer? Yes, remember to apply your exponent laws. Remember that when you're multiplying, you're adding exponents. And remember, guys, as I've already discussed with you in the very first example, if there is no exponent written down for a variable, there is actually an exponent of 1. So, for example, in this first bracket, both m and n don't have exponents written down, but they do both have an exponent of 1. So bear that in mind, terrible color, bear that in mind when simplifying. I'll give you another 10 seconds. Okay, so m times m is m squared times m cubed gives us m to the power 5, i.e. add the exponents. 1 plus 1 plus 3 is 5. Then in terms of our n's, I've got 1 plus 2 plus 1, or n times n squared times n, which gives us n to the power 4. So I have simplified and found my product of 24 m to the power 5, n to the power 4. And this is, again, not rushing this, not trying to do it all in one go and just find an answer, step by step. Right, this is where we go wrong with exponents. We try and rush stuff instead of just doing things slowly and taking our time in doing these questions. Alrighty, so I'm going to give you one that I would like you to try by yourselves. Oh, sorry. No. Right, guys, so I want you to try D here for me. Try it by yourselves. I'll make this a bit bigger. I will go back to question C for you to take screenshots. Actually, let's maybe do it like this. There we go. So try question D. I will make the font bigger, seeing as I've now made it smaller. And on the chat, let me know what you get as your answer there. Remember your signs, numbers, variables. Don't rush it. Do it step by step so that you are making sure you are getting the right answer. Okay, we've got one answer so far. Keep them coming. Remember, guys, whenever there's a negative, you need to think very carefully about whether or not your answer is going to be positive or negative. Remember your exponent law. Remember that when you're multiplying, we add exponents. And you can only do that when your bases are the same. Remember, guys, the exponent law for multiplication is to add your exponents. Be very careful that you are correctly adding your exponents. I'm going to give you 60 seconds. All right, guys, let's have a look. So we start with our signs. If we look at our signs here, we've got a positive times a negative times a positive. A positive times a negative is a negative. A negative times a positive is a negative. So what that means is that my final answer is going to be negative. Then I look at my numbers. 2 times 3 is 6, times 10 is 60. So we've got a value of negative 60 as our coefficient. Then I go and work with my exponents. So what I see is that I've got variables x as well as variables of y. So I need to deal with them separately. I can't just lump them all together. If I start with the x's, I've got x squared times x, which has an exponent of 1, times x to the power 4. So I add my exponents to get x to the power 7. I've got a y, which has an exponent of 1, times y cubed times y to the power 7, which gives me y to the power 11. And so I have simplified my expression. Now, guys, just quickly there, I'm going to say words and now they have disappeared. No, you can just ignore me. I don't know what my words were. Don't worry. Right, so SNV, signs, numbers, variables. Make sure you're going step by step. Right, if you have got any questions, now's the time to raise your hand and ask. Otherwise, you're taking screenshots of C and D, and then we're moving on to see how we deal with division. JD? Oops, sorry, I need to unmute you. There we go. There's JD, Jadley. Should be a pop-up to unmute. There we go.
May I please ask a question?
Yeah.
So I'm asking here, what do you do? How do you get your x to the power of 7?
Okay, so remember what we do is we add all of the exponents to x. So if I look at all the x's that I've highlighted in blue, I'm going to take the 2 plus the 1 plus the 4. So 2 plus 1 plus 4 gives me that x to the power 7 because my exponent law tells me to add the exponents when I multiply.
Okay, ma'am.
Good. Right, guys, I hope we've all got our screenshots. Let's have a look at some division. Right, so now remember again, when we are dividing with exponents, the rule is we can subtract our exponents in order to simplify. Personally, I don't actually do that, but it doesn't really matter. If we have a look here, we've got x to the power 18 divided by x to the power 12. So I always take my top exponent and subtract the bottom exponent. So I've got 18 minus 12. Now 18 minus 12 gives me 6, and I have simplified that expression. How I like to do this personally is I like to break down what the exponent is actually telling me. So remember, x to the power of 18 tells me that I am multiplying x 18 times. And so what that means is I have got 18 x's in the numerator. And so in the same sort of thinking, in the denominator, I've got 12 x's. Now, if you think about division, if you had 3 times 3 times 3 divided by 3 times 3, we know that whenever we divide something by itself, it's 1. So we can essentially cross cancel. And that's essentially how I like to deal with division. So I like to say, okay, all 12 of my x's in my denominator can cancel with 12 x's in my numerator, leaving me with 6. So you end up with exactly the same answer. But if you're more comfortable applying your exponential law of subtracting, that's absolutely fine. No issues whatsoever. But the takeaway here is that when you are dividing with your exponents, generally your exponent should get smaller unless we've got a weird situation going on, and this goes back to BK's question. But generally, we apply law 2 that says when we divide our exponents, we subtract them. Right, so if we have a look at question B, this is now again ramping it up. So again, SNV applies to you dividing or multiplying. SNV applies to both. And so if we are going to apply that to this division situation, we again need to think about our signs, our numbers, and our variables. So in this question here, we've got a positive divided by a positive, which means my answer is going to be positive, so no issues there. Then I need to deal with my numbers. Now, guys, the numbers are the coefficients. So what we have here, if we take it out and just consider the numbers, is 2 divided by 4. Now, you need to be so careful. When your numerator is smaller than your denominator, you're going to end up with a fraction. 2 divided by 4 simplifies to a half. It simplifies to a half because both of these can be divided by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. I've simplified 2 over 4 to give me that half. And so what that means is my answer will have a fraction, 1 in the numerator, 2 in the denominator. Then I need to go and deal with my variables. So here I've got an x and an x. I also have got a y squared and a y. So if we now want to consider our variables, let's start with the x's. Okay, so we've got x divided by x. Now we've had this conversation already, actually. If we've got x divided by x, technically those are both exponents of 1. So if you wanted to apply your exponent law, you would say 1 minus 1, which is 0. But we have discussed the fact that anything to the power of 0 is 1. Technically, what that means is those x's just cancel out. So you don't have any x's left in your final answer. They have canceled. However, when we look at the y's, we've got y squared, that's in our numerator, divided by y, which has an exponent of 1. Our exponent law tells us to subtract the exponents, leaving us with y, or y to the power 1. Now, this is why I don't particularly like this law, is because sometimes we get ourselves confused. This answer is technically or needs to go into the numerator. Okay, if you think about the cross-canceling method, I'll come back to that now. If you cross-cancel, you've got 1y at the bottom canceling with 1y at the top. Your leftover y is in the numerator. And this is why what I've said here is that your answer when you subtract goes into your numerator. So that therefore means that I am left with a y in my numerator and no variables at all in my denominator. Now you can write this answer either as 1y over 2, or you can just write it as y over 2. Remember, you do not have to write that coefficient. What is important here, grade 8s, is that in your denominator, you have got a 2 and no variables, and that in your numerator, you have got y. Okay, so when we start to introduce values and start to introduce multiple variables, we do need to be careful when we start dividing. Oh, excuse me. So take your screenshots of those 2 questions, and if you have any questions you would like to ask, please raise your hand now so you can ask them and I can explain whatever it is that might be confusing. And again, guys, just like with multiplication, do it step by step. There's absolutely no need to rush it. Alrighty, so let's have a look at question C. Now again, as we start to do more and more, the complexity increases. And so this is now an example where we may need to simplify what's going on in our fraction first before we just start jumping into things. So whenever I see that I've got lots going on in either my numerator or my denominator or both, what I want to do is I always want to simplify first. We're going to make a little note here. We're going to simplify numerator or denominator, depends which one needs simplification first. In this case, we're going to simplify our numerator first. So what that means is I need to look at this numerator and I need to deal with this multiplication. Let's try that again. I need to multiply those two terms together. So again, think about SNV. A negative times a negative gives me a positive. There is a coefficient of 1 to that b. So when I get to my numbers, 2 times 1 is 2. And then my variables, I've got an a cubed and I've got a b. They're different. So I've just got a cubed b as my product. This has simplified my numerator, as I said we need to do. And now we can deal with our denominator. Now, guys, remember, again, this negative outside the bracket is technically a negative, currently triangle, is technically a negative 1. So you are saying negative 1 times 4ab, which hopefully we know gives us negative 4ab. So using signs, numbers, variables, every single step of my way, I'm simplifying. Now that I've got a much simpler fraction I can work with, I am again going to use SNV. Signs, a positive divided by a negative is a negative, so I know my answer is going to be negative. Numbers, we've just dealt with one like this. We've got 2 divided by 4. The bigger numbers in my denominator, so that means I've got 1 over 2. Remember, I explained how this was simplified in the last question. If you don't remember, there it is. And then we've got our variables. Now again, look carefully at what variables we have. We've got an a cubed and an a, and then completely separately, we've got a b and a b. Now, hopefully, again, from the conversation we've just had, we realize that those b's are going to divide away. B divided by b is 1, so it cancels or it falls away. And so what we have is the a cubed divided by a. So if we take our variables and we think about this, this is then technically, according to our law, a to the power 3 minus 1, which leaves me with a squared. And that answer goes into my numerator. So here I have simplified this to negative a squared over 2. You want to write negative 1a squared. That's fine. Makes no difference whatsoever. It is completely up to you how you choose to write it. Personally, I don't write my coefficient of 1. I would just leave it as negative a squared over 2, but it's completely up to you. All right, guys, so, sure, I didn't leave myself much space, did I? So I want you to take screenshots of these. I'm just going to move this up. And if you have any questions, now, again, is the time for you to raise your hand and ask. So grade 8s, we have to be mindful of all of the components of our expression as we are going and simplifying these expressions. Semtanda, yes, the answer always goes to the numerator. I don't want to say what complicates things, but what we need to bear in mind is when next year we start dealing with negative exponents, we'll have to think about where that is. But basically, the way I like to think about it is I like to think about, if we look at question C, my leftover or my answer when I subtract goes to where the exponent was bigger. So for example, here we can see that my exponent for A, let's get another color. My exponent for A was bigger in the numerator. So this answer that I'm getting must go into my numerator. That's how I prefer to think about it. So let's actually write this down. So this goes to the same position of the original biggest exponent of the variable. So because the biggest exponent of A was originally in the numerator, that answer goes in the numerator. If, for example, it was the other way around, so if, for example, this was A over A cubed, my biggest exponent is then in the denominator, so that A squared would then go in the denominator. But like I say, this is very much a grade 9 concept, and so you deal with this in grade 9, not really in grade 8. Just want to take that off to avoid any confusion.
Do we get one more time, one more practice? I just want one person to get it right this time. Which one are we taking? This one.
Okay, guys, so like Yolanda says, I want you to give this one a try by yourselves. We've basically done one like this right now in question C. So let's just move this up. So remember, simplify what you have going on in your numerator and or denominator first. And once you've done that, apply your SNV. So I'll leave question C up there to hopefully help you along. I want to see answers for D in the chat, please. Remember your SNV and go step by step.
Let's go, guys. Who's taking this one home? Let's see who is going to be the winner. You put your final answer there, okay, on the chat. I'll definitely be judging you on top of that. So make sure you put it on the chat. Let me quickly check my answers. Cancel. Whoop, nice. Got it. Let's go, guys. No, not correct. Vaisha, give it another try. I've done the button. Good try though. Let's keep going. Let's keep trying. Dum, 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 dum. Dum, 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 dum. Guys, come on, let's do this.
Guys,
Check
do
your
it step by step.
numbers.
Yeah,
Yeah.
step by step.
Now I cannot say the name. Let's go. Everybody, put your answers. But we already have a winner.
Nelson, if I'm not mistaken.
Okay.
Okay, so who wants to raise their hand to explain this one for us?
Everyone who got -4, please raise your hand.
I think Nelson was the first one, but there we go. Tandawake, help us out here.
Okay, ma'am. So as well as -8 times 2, it gives you -16.
Good.
And then okay, and then I haven't I'm just left the B squared and the A.
Good.
Okay, and then I just said -16 divided by 4 gives you -4.
Good.
Okay, and then
What happens to the, sorry, yeah, carry on, sorry.
Okay, and then for y, and then for A minus A, it just cancels out, so there's nothing.
Good.
Okay, and then for B squared and squared, it cancels out, there's nothing. So you're just left with -4.
Excellent.
Well,
So guys, really importantly there, like Sandra, like you said, the A's and the B's actually cancel because A to the power 1 minus 1 is A to the power 0, which we know is 1. It cancels. B to the power 2 minus 2 is B to the power of 0, which is 1. It cancels. So all we are actually left with there is that -4 as our answer.